Hello guys, hope you're doing well, and as always, if you're new to my channel, I would request you to subscribe to my channel so that you shall be able to watch all my related engineering videos. Thank you. Alright, just to continue our static concept builder questions, this is part number 5. Okay, so we have a new set of questions that will increase our basic understanding of statics, engineering statics. Okay, so let's start with these questions. So we have technically been given as over 6 questions, A, B, C, D, E, F. Okay, the first question is basically telling us that you need to define two force member and three force members with some practical examples and applications where it is being used. Okay, in basically the previous static concept videos I have already explained what is two force member. Okay, so you can just go and see that the explanation, and practically I have shown it you with practical different curvilinear rods. Okay, so if we go over here and to see its precise definition. Okay, so if you look at it here, it is in my video frames and machines theory part 2 of 2. If you look at it, I have basically been explaining you what are basically two force members, and they are giving you an example over here. Okay, for two force members, and here is a complete definition for a three force member, and basically how a three force member could be developed with these steps, and these steps. So these are basically the three force members, basically free body diagrams and for a three force member, and the definitions are here. This is a two force member. So you can just watch this complete video. Apart from that, you can also go over here. Also in my this video, 2fm versus 3fm versus 0fm, a very important video. Okay, it also explains the concept of two force member, the concept of three force members, and it is also explaining you the concept of what is called as a here it is a three force member, and also explaining you the concept of a zero force member with practical pictures and explanations. Okay, so you can just go here and basically see how a zero force member is defined, a two force and three with practical examples. So this is how you shall be solving this very small 2 marks problem with practical applications. Again, the other question over here is basically the two externally applied loads on any structural system are dash and dash. Okay, so this if you look at it basically in the previous basically video of static concepts I have already explained. Okay, and you know it very well. They are basically the externally applied loads on any structural system are basically the forces, forces and the moments. Okay, okay, then comes the concept, another very conceptual problem is the projection of a vector on an axis is a vector. Okay, so he's telling you that the projection of any vector on any axis, is it going to be a vector? You will call it also a vector, you will not call it a vector. Okay, so in order to understand this problem, we can just prove it and show it by this. If, for example, if you say we have one vector over here, and you can say we have basically what is called as some axis over here. Okay, this is our one axis, and if you look at it, there is going to be another axis over here. Okay, so you know if this is a vector, he is telling you if this is our vector, this is a vector which is called as P. Okay, so this vector will be called as P. Okay, so this is P vector. Okay, so its projection on this axis will be basically, this will be the projection on this axis. Okay, so if and we say this is our x-axis and this is y-axis, so the projection of this on this axis is going to be, this is our projection. If you look at it, it will be this. Okay, it will be this projection. So if it is this, what we are basically explaining, this is number C. Remember, just don't forget it, this is C. So this is the projection. Okay, but if you look at it, the projection of this vector on say x-axis is a vector. No, it is not going to be, because it is a projection, it is a shadow, it is not going to be a vector. So you can very easily write the answer to this problem as it is false. Okay, because the vector is P making some angle theta with the x-axis, and the projections are basically just the shadows. Okay, so then again, if you look at this problem which is coming over here to you, and this is basically define zero force member and a rigid body. Okay, so if you want to understand what is a zero force member, I have just go through this video, and it is fully explaining you what is a zero force member, and it is not only explaining what is a zero force member, but it is also telling you a practical example over here also. If you look at go through in this video, it is also showing you each and every explanation of how a zero force member is basically being searched in an array of trusses, and there is a technique which is being shown you over here. If you look at it, this technique of identifying a zero force member. Okay, so this is being explained in this way, and again he says over here to you that total reactions given by a ball and socket joint and a fixed support in 2D are dash and dash. Okay, for if you go here, and he's telling you for what is called as number E. Okay, this is number E. So for E, again ball and socket joint is if you go here, and if you go here and you go here basically, and if you go here to 2 3 8, so okay, these are what is termed as our supports for rigid body in 3D. So if you look at over here, and this you must learn this, you have to learn this FBD of 3D supports. If you look at it, you can see there's a ball and socket joint over here. Okay, and this ball and socket joint will give you three reactions: Fx, Fy, Fz, and are three rectangular force components. Okay, so this is how you will solve this part. And what about the other one he has given you over here is he says the fixed support in 2D. The fixed support in 2D, you again go over here, and you try to search for fixed support for 2D, and here you see the picture supports in 2D, and he's saying you fixed support. Okay, so if you look where is our fixed support over here, is basically where is the fixed support, this is the fixed support. This is a fixed support, but this is in 2D. So in 2D it will give you three unknowns. It will be two reactions and one moment. Okay, you have to be very careful that if he asks you for example and he asks you that what will be the reactions of the fixed support in 3D. Okay, so it will be totally different than here, because in 3D if you go for a fixed support, here is the fixed support in 3D. This will give you six unknowns, so don't get confused. And the reactions are three forces and three couple moments. Okay, the three forces are Fx, Fy, and Fz, and the couple moments are Mx, My, and Mz. I hope this basically clearly understands your concept of this question also. And then we go to another problem. So you can just write over here if you want to. For the answers for the C are basically three reactions, and what will be there? Fx, Fy, Fz. Okay, and for the other one, for the fixed support, it will be six reactions. And sorry, it is basically in 2D. He says in 2D. So in 2D basically we have to basically clean it up. In 2D it will be, in 2D it will also be three reactions. Okay, so it will be Fx, Fy, and Mz. Okay, so again three reactions, and you have to explain for the ball. This is for the ball and socket joint. Okay, this is in for 3D. Remember, this is for 3D. This is for 3D, and this is for 2D. Okay, so I hope this clearly understands your basic concept for this. Now another problem has come up to us, and he says draw a non-coplanar force system which is concurrent with a line versus a coplanar force system which is concurrent at a point. Okay, this is very simple. Coplanar force system concurrent at a point. How would you basically search for this? So if you go here, and if you basically see this picture. Okay, if you see this picture, Remember 2D equilibrium force system, name of the video. You go. This is basically a coplanar force system. This is basically your coplanar force system, and if you look at this coplanar force system, this is concurrent at a point. So you have to draw this picture, and the independent equations are this, and this is the figure that he's asking for you to draw. Okay, you can either go for this video, or basically you can also take this also. Basically here the coplanar concurrent forces, which is basically uh, here this is a coplanar concurrent forces, this D. It's the same thing. You can take any picture, draw any picture, so you have a double understanding of the concept. Okay, so if, and what about the first one? This is a bit typical. He says draw a non-coplanar force system which is concurrent with a line. Okay, so how we go for this? If you go here, and for this, if you look here, remember 3D non-coplanar space force system study. This is the name of the video. If you look at this thing, he explains you non-coplanar concurrent forces. All the forces do not lie in the same plane. Yes, it is non-coplanar, but their line of action passes through a single point, and it is basically concurrent. Okay, so that is what he is asking. Okay, so that is what he's asking. Okay, coplanar concurrent with, but he's saying with a line. He's telling you with a line. So you can basically take the same picture, and if you want, you can basically just sketch it something like this, and you can in the same plane. Okay, you can just sketch it. This is with the line. A point will be lying on a line, but this is the picture of the one he's asking for you, slightly changing from a point to a line. Okay, so you can basically draw this to get the maximum numbers. So these are the things that are very important, a very typical set of knowledge questions for statics. Okay, with this I complete. Please say thank you to all, and I wish you best of luck for all your future endeavors. Thanks a lot, and you have a very wonderful day. Bye.